What's up? I'm Vin, and today I want to go through the 2023 STAAR Redesign Algebra 1 practice test, and I'll leave a link to a copy of this test in the description below. Now let's get started. Now here are some of the formulas that you're going to get in the reference page. You get a few formulas for factoring, properties of exponents, linear equations, and quadratic equations. So these will help us out as we go through the 50 questions here. Question 1, which expression is equivalent to, and we have this product here. And for a situation like this, the first thing I would do is multiply the numbers together. So I'm going to do 2 times 5 is 10. And now I'll multiply the variables together. So the rule that we're going to need here, or the property of exponents that we're going to need, is when we have a product of two exponents that have the same base, we just add the exponents together. So a to the b times a to the c would be a to the b plus c. So in a situation like this, I'm just going to add these exponents. I'm going to do 4 plus 8. And this is going to simplify now to 10m to the 12th power, and this matches up with choice B. Question 2, we have the function f of x equals x was transformed to form g of x equals f of x minus 23. And we want to know which statement is true about the graphs of f and g. Well, just know if you take a function and you just add or subtract some number, that's going to be a vertical shift. So this is going to take the graph of f of x and it's going to shift it down 23 units. Okay, so we're going down 23 units. So what I imagine for a question like this is that we have the graph of f of x equals x. So this is not going to be drawn to scale, but I'm imagining the line y equals x, or f of x equals x. And if we move it down 23, it's going to be somewhere over here. This is not necessarily drawn to scale. But what is going to happen is we're going to have a line that is parallel to the original line. Okay, so the graphs of f and g are going to be parallel. So we could get rid of choices A and B, because those two answer choices are saying not parallel. And the new line is going to be shifted 23 units down, okay? So we would go with choice D here. But if we really needed to be sure, we could use the calculator. So for something like this, I would just go over to the y equals and type in y equals x. And then we're also going to look at the function f of x minus 23. But f of x is equal to x, so I could just write x minus 23 here. And now if I graph this, I'm not going to be able to see what's going on here because I'm going all the way down to minus 23. So for this, I would go to the window and I would make my lowest y value, let's say something like negative 50. And now I press graph and you could see I have my line. My new line is 23 units down and it's definitely parallel to the original one. So that's how I know choice D is good. Question 3, we have a graph of a quadratic function is shown and we want to know what are the x-intercepts of the function, and we have to shade the two correct circles that represent the points. Now the x-intercepts are the points where the graph crosses the x-axis. Okay, so this is where the graph crosses the x-axis. This is what we're looking for. So for this, if we just look at the graph here, we could see the x-axis is over here and the 2 points are going to be located here and here. Okay, so if we had to actually write the coordinates, this would be the point -1, 0. And the second point over here would be the point 3, 0. But all we have to do is shade the two circles. So these would be our 2 points. Question 4, we have an artist bought a set of 10 paintbrushes that contain X small paintbrushes and Y large paintbrushes. And then we have the number of small paintbrushes in the set was 4 times the number of large paintbrushes in the set. And we want to know which system of equations can be used to find the number of small paintbrushes and large paintbrushes in this set. Okay, so for this question, there's a lot going on, but if we reread this very carefully, there are 10 paintbrushes in the set, and there are X small paintbrushes and Y large paintbrushes. So right away, we could say that X plus Y is equal to 10. Okay, because if you think about the entire set of paintbrushes, there's going to be X small ones, Y large ones, so if we add those two together, that's going to give us the total number of paintbrushes. So right away, I could see we're going to get rid of these two answer choices because we're adding X and Y. And now for this last part, I would once again just reread this a few times just to make sure that the second equation you choose or that you set up is correct. So here we have the number of small paintbrushes in the set was 4 times the number of large paintbrushes. So for this one, what I'm imagining, just so that I set this up carefully, is I have small paintbrushes and I have large paintbrushes. So what I know is that, let's say I have 4 small paintbrushes. That would mean that I have 1 large paintbrush, because what they're saying here is the number of small paintbrushes in the set was 4 times the number of large paintbrushes. So whatever amount of large paintbrushes we have, there are 4 times as many small ones. Okay, so we can even see that the combination here has to be 8 and 2. But the point of me thinking about this is that I set up the second equation correctly. That if x represents the number of small paintbrushes and y represents the number of large paintbrushes, the relationship between x and y is that x is equal to 4 times y. That I would have to multiply my y values. We'll make this a little neater. I would have to multiply my y values by 4 to get my x values. Okay, so that's why x equals 4y, and choice A would be our answer. Question 5, we want to know which graph represents f of x, and we have this exponential function here. So if we want to practice this first without a calculator, and then I'll use the calculator just to be 100% sure what our answer is. To do this without a calculator, what jumps out at me is that we have an exponential function because we have a number to the x power. But notice that our base, 2/3, is between 0 and 1. So this tells us that we have exponential decay. Okay, so I'll abbreviate exponential, but we have exponential decay, which is when the graph is dropping like this. Okay, this would be an exponential increase if the graph is going up. And that would be in a situation where we have something in the form of like y equals a times b to the x, and b is some number greater than 1. Okay, but this is not the case here. So that's how I know this answer choice and this answer choice are out. And now the next thing I could do is just plug in 0, because notice that over here when x is 0, y is equal to 1. And when x is 0 on this graph, we have y is equal to 3. So if I plug 0 into the function, I have f of 0 is equal to, and I have 3 times 2/3 to the 0 power, and then 2/3 to the 0 power is 1, and 3 times 1 is equal to 3. So this tells us that this function 0, 3 should be a point on the graph of the function. And notice that corresponds with choice C, that 0, 3 is this point over here, but this graph would have the point 0, 1, not 0, 3. So that's how I know A is out. But of course, if we just want to use the calculator, we could go over to the y equals and we clear out what we had from before. And I could just type in 3 times parentheses 2/3. I close the parentheses and I'm raising this to the x power. And now my graph is going to be all out of whack. So I'm going to press zoom 6 to put it back to standard here. And notice that this does match up with choice C. Notice that our graph hits the y-axis at 0, 3. It doesn't hit at 0, 1. If I wanted this to hit at 0, 1, then we would just change the 3 in front to a 1, or we could just get rid of it altogether. You could see if I deleted this, then I would have my exponential decay graph here hitting the y-axis at 1, but what we have here is the graph is hitting at 0, 3, so choice C is definitely our answer. Question 6, we have this quadratic function f, and the solutions to the equation f of x equals 0 are x equals 7/5 and x equals -2/3. And we want to know which function could represent f. Now, one thing we could do here is just use the calculator. We could plug these x values into the equations here and see which one gives us f of x equals 0. Or we could graph all of these and see which ones hit the x-axis at 7/5 and -2/3. But if we want to do this with just algebra, what we could do is we could start off with the roots x equals 7/5 and x equals -2/3, and we could work our way backwards to the function. Okay, what I'm thinking of is if I had something like this, let's say I had this quadratic equation, and I factored this to x plus 2 times x plus 3, and from here I set each factor equal to 0. Okay, so this second one says x plus 3. We do x plus 2 equals 0. That's going to give us a root of x equals -2. And then if I set x plus 3 equal to 0, this would give us a root of x equals -3. Okay, so that would be if I'm going from start to finish this way, from the equation to the roots. But if I'm starting at the roots, I need to work backwards. Okay, so from here, what I would do is I would subtract 7/5 on both sides. So I have x minus 7/5 is equal to 0. And then for this, I would add 2/3 to both sides. I would have x plus 2/3 is equal to 0. All right, and now I'll just start to erase what we have here. So what happens then is that I have my factors expressed here, and I could multiply them together. But notice that this answer choice, we have all whole numbers. So basically what would happen here is I would multiply this first equation here by 5, and I would multiply this second equation here by 3. And this would give us, in the line above, I would have 5x minus 7 is equal to 0. And this would give me 3x plus 2 is equal to 0. And you could even see that if I solve these equations here, 5x minus 7 equals 0, I'm going to get x equals 7 over 5. And if I solve this equation, I'm going to get x equals negative 2/3. Okay, so I'm just, once again, I'm working backwards. All right, so now this step I honestly just do in my head, but I'm just showing how to get from this step here to the step before it. And now what I do is I go with the factors, and I'm going to multiply those two factors together. Okay, I'm going to multiply 5x minus 7 by 3x plus 2. Okay, because once again, when we start from the equation, we are factoring the original equation here, and then we set each factor equal to 0. So if I'm starting from this step now, I just have to work backwards by multiplying. Okay, so that's exactly what I'm going to do here. So now I'm going to multiply this out, and we have 5x times 3x is 15x squared. So right away, I could see these two answer choices are gone. And then I have 5x times, we'll just make that neater. We have 5x times 2 is 10x. We have to distribute the negative 7 now, and we get negative 7 times 3x is minus 21x. And then we have negative 7 times positive 2 is negative 14, and this is all equal to 0. And now if I combine like terms, I have 15x squared, 10x minus 21x is minus 11x, and I have minus 14 is equal to 0. Okay, so we'll just make this a little neater. So our function f of x is going to match up with choice B. But once again, we have a calculator, so we could just do something like this. We could do 7 over 5. 7 over 5 is equal to 1.4. And I could just start plugging that into all the functions. Like I could do 15 times, and then I'm going to put 1.4 squared. And then we have minus 11x, but x we're going to claim is 1.4. And then minus 14 at the end. And this should give us 0 if we did this right, and it does. Now, if I wanted to check negative 2/3, I would just repeat this process, but I would replace the x's with negative 2/3. So that's one approach here, is to just plug the x values into the functions and see when we get 0. Another thing we could do here is just graph all of the equations. And if I have 15x squared minus 11x and then minus 14, notice that by the time I graph choice B, so I press graph here, I have two roots. And my roots occur at negative 2/3 and 7/5. If I wanted to be 100% sure, I could press second trace 0. And what I do is I go, let me just make sure I'm in the neighborhood here. So I scroll, and there's my pointer. I press enter once. I scroll to the right until I go from the positive to the negative. I press enter a second time and a third time, and there's our negative 2/3. Okay, another thing you could do is you could just graph the line y equals 0, and you could do second trace intersection option 5. And then when you do it this way, all you have to do is get close to the point of intersection and press enter 3 times. And the calculator is going to give you the root x equals, in this case, 1.4 is the second root. Okay, so we can use the calculator and not do any of this algebra, but it is an algebra test, so I did want to show an algebraic solution. Question 7, we have a store manager adjust the price of an item each week that the item goes unsold. And the price of the unsold item in dollars after X weeks can be modeled by the exponential function f of x, and we have is equal to 320 times 0.90 to the x power. And we have to select one correct answer in each box to complete each sentence. So we have the initial price of the item before the store manager made any adjustments was. So that's the initial price. That's when x is equal to 0. So we plug in 0 to the function, and x represents the amount of weeks that the item went unsold. So at time 0, we're looking at x equals 0. So we have 320 times 0.90 to the 0 power. And just know that 0.90 to the 0 power, we could use a calculator, is equal to 1. So we have 320 times 1, which is equal to 320. Okay, so this is going to match up with B. Now, to get the rest of the question here, it really helps to know this formula. A equals P times 1 plus or minus r to the t power. Okay, so this is our compound interest formula, but it also takes care of cases where the price of some good is decreasing. Okay, the plus or minus, plus is when the price goes up, and then minus the rate would be when the price is going to go down. So I notice here that this value 0.90 is less than 1. So that's how I know it's going to be a 1 minus situation. So if I do 1 minus r is equal to 0.90 and I solve for r, what I would do here is I could just do this in my head and say that r is equal to 0.10, or I could just do the algebra here and work this out. Okay, so let's say I don't do that math in my head and I had to do some algebra. What I would do is I would just go -1 on both sides and think of that as -1.0. And what we're going to have is negative r is equal to, and if this mental math isn't coming to you, you just use a calculator, but this is going to work out to negative 0.10. So if negative r is equal to negative 0.10, we could just multiply both sides by -1, and this tells us r is equal to 0.10. Okay, so this is our interest rate here, or in the context of this question, it's the percent off that the store manager is taking off the price of some good every week this item goes unsold. So the price of the item is definitely decreasing here because, once again, the 0.90 is less than 1. Okay, so we have a decrease. We have 1 minus r. But now the r value, if we look at 0.10, we just have to recognize here that this is equal to 10%, which is 10 out of 100. Okay, 10 out of 100 gives us 10 hundredths, and this is equal to 10%. So that's how we know that it's decreasing at a rate of 10%. The problem with choice B here is that if we had a decrease of 90%, we would have, if we look at that over here, we would have 1 minus 0.90 is 90%, 90 out of 100. And that's equal to 0.10, but the base of the exponent here is not 0.10. And then the problem with 1.10, or I'm sorry, 110%, that would be if we had 1.10 like this to the x. Okay, that would be if we had 1 plus 0.10. So that's why choice C is no good. So these are definitely our correct answers. Question 8, we have to know how to simplify radicals. So something like radical A times radical B, I could express as radical A times B, provided that A and B are both positive. Okay, we're not dealing with imaginary numbers on this test. So here what we have is we could break this down into 2 square roots. So 75, I would want to factor to 25 times 3. And when I factor a radical, a square root radical, I am using numbers when I factor that are perfect squares. Okay, I'm looking for the biggest perfect square factor of the number under the square root. So 25 is the number that we're going to go with. And now the square root of 25 is equal to 5, so we have 5 times the square root of 3, and this matches up with choice A. But of course, for a question like this, we can just use the calculator. So if we do square root of 75 and we hit enter, there's the actual question. If I type in 5 times the square root of 3, I'm going to get the exact same decimal. If I type in one of the wrong answers, like let's say 15 times the square root of 5, notice that the decimal that I get here does not match the decimal in the original part of the question here. Okay, so you could do the same thing throughout the rest of the answer choices, and choice A is going to be the only one that matches the original. So A is our answer. Question 9, we have a fish tank is being drained at a constant rate, and the graph shows the linear relationship between the volume of water in the fish tank in liters and the time in minutes the tank has been draining. And we want to know which value best represents the rate of change of the volume of water in the fish tank with respect to time. So for this question here, we're looking for the slope. Since our function here is a linear function, we are looking for the rate of change, and the rate of change of a line is the slope, and the slope is constant throughout the line. So we could just find the slope between any 2 points, and let's go ahead and use these 2 points here because they're the most obvious. So this is the point 0, 60, and this is the point 10, 0. And for this, we're going to use the formula. We have x1, y1, and x2, y2. We could use the slope formula, which is, well, right over here, we have y2 minus y1 over x2 minus x1. Okay, some people just say rise over run for this, and you can just count the rise over the run, but just be very careful here. The y-axis is being scaled by 10. Okay, we're counting by 10s here, and we're counting by 2s over here. So that's why writing out the coordinates could just help make sure that you're staying accurate here. So now we're going to have m equals, and we're doing 0 minus 60. Okay, I'm doing y2 minus y1, and then I'm dividing by x2 is 10 minus x1 is 0. And now the slope, I'm just going to simplify here. We're going to have negative 60 over 10, and that simplifies to negative 6. Now, one thing, all of the units and all of the answers are the same. But how do we know the units here are liters per minute? Well, the difference in the y values, the units on the y-axis here, it was volume of water in liters. Okay, so that's why we could just put a liter up top to go with the difference of the y values, and the units on the x-axis is minutes, so we could put minutes underneath. So it's liters per minute every time we simplify here. And for this, if we have everything simplified at the end, the slope is going to be -6, and we have liters per minute. Okay, so now we just scan the answer choices here, and this is going to match up with choice A. Question 10, we want to know what is the solution set for this inequality. And there's a few ways we could do this, but one way would be to start by distributing the 2. So I could do 2 times w is 2w, and 2 times -18 is -36. And now everything else just carries down. We have our greater than sign, and the left side is 12 minus 4w. So now from here, what we could do is we could get the w's to the left, so that when we solve, it'll say w is greater than or less than, depending on how this question goes. So we're going to do minus 2w on both sides. And now on the right side, these terms cancel, and we have 12 minus 4w minus 2w. I'm doing -4 minus 2 is -6. So I have -6w. And now greater than, all we have left on the right side is -36. So now we'll do minus 12 on both sides. And that's just going to get the w term closer to being alone. So we have -6w is now greater than -36 minus 12 is -48. And now from this step, we're dividing both sides by -6. And just know when you divide or multiply both sides of an inequality by a negative, the sign flips. So now this becomes w is less than -48 divided by -6 is +8. So we get w is less than 8. Choice C is our answer. Question 11, we want to know what are the factors of, we have 2x squared plus x minus 15. And for this one, we can use the calculator, but first I'll do the AC method. And we call this the AC method because if I write out the general form of a quadratic equation, ax squared plus bx plus c, the AC method targets the a term and the c term. So when I talk about the AC method, I'm talking about doing the product of the a and the c term. So I'm doing 2 times -15 is -30. And then my b term is equal to 1. That's the coefficient of our x term. And now the way the AC method works is we think of two numbers that have a product that is equal to the AC term, and the sum of the two numbers is going to be equal to the b term. So for this, you just have to be really sharp with your mental math, your times tables, and your integers. So you think about this carefully. The two numbers that are going to work are 6 and -5. Okay, 6 plus -5 is +1, and the product of those two numbers is -30. So then what I do with 6 and -5 is I rewrite the middle. So I'm going to take this expression and I'm going to write it now as 2x squared plus 6x, and then I have minus 5x, and then minus 15. And notice if I do 6x minus 5x, it brings me right back to where I started. And now what I do is I do factoring by grouping. So I'm going to take out a 2x, and in parentheses, I'm going to have x plus 3. And now here, I could take out a 5, but I'm going to take out a -5. The reason being the leftovers are going to be x plus 3. My goal when I do the AC method and then factoring by grouping is I want my terms on the inside to match. And notice that we have matching x plus 3s. If we were to take out just a +5 instead, then we would have minus x minus 3, and then these wouldn't match. So now I could factor out the x plus 3, and I just write the leftovers. I have 2x left on the first part, and I have -5 left over on the second part. So I'm looking for x plus 3, and I'm looking for 2x minus 5. So these are the two correct answers for the factors of this expression. Now, one extra detail I want to point out before we move on is if we go to the y equals, and we type in the original expression 2x squared, and then we have plus x and minus 15. One thing we could do here is when we graph this, notice that, and I'll erase the y equals 0 underneath, is that we have this quadratic, and I have two roots here. So if I start typing in the factors, like let's say I type in x plus 3, notice that this red line here is hitting the x-axis at the same location as the graph in blue, which is this quadratic. So that tells me right away x plus 3 is one of the factors because the root that I'm getting from there is matching this. So That's just something to be mindful of. Now, if I want to play this guess and check game, I can go down the line and just start typing in the rest. Like I could do 2x minus 3 and see which other ones are going to match up here. But watch, when I type in one of the wrong answers, you can see that it's not hitting the root at the same place. If I were to type in, let's say, 2x minus 5 instead, this would give us, see, it would hit at the other location. And now I would say, all right, well, let's see what happens when I write them next to each other. What happens when I do x plus 3, and then I multiply by, next to it, 2x minus 5. So this is just a way for me to find the factors with the calculator. Notice that I get the exact same graph because the graph in red and blue overlapped completely. So these two factors are definitely good. Question 12, we have a part of a quadratic function f is graphed on the grid, and we want to know what is the domain of the part of the function shown. Now, the domain is the set of all possible x values. And if I wanted to find the range, that is the set of all possible y values. But here we're looking for the domain. So when I'm looking for the domain of a function, I'm looking for one, where does the function start and where does it stop? So I look at this function here and it's starting here. It's starting at the point -1, 2. And we have to be very careful here and notice that this point is solid, okay? It's colored in. So that means we're going to be including the endpoint. And now I look at where does this function end? This function has no end, okay? This function has no end. It just keeps going on forever. So now, once again, the domain is the set of all possible x values. So if the first point here is starting when x is equal to -1, -1 marks the beginning of the domain, but we just keep going to the right, okay? This function has no end, so that means our domain is going to continue all the way to the right like this. So if we wrote this in interval notation, I would put a bracket around -1, and this keeps going to infinity. I would put an infinity like this. However, this is expressed in a different way. We have in the answer choices here, all real numbers greater than or equal to -1. So another way to express this set of numbers here is I could say x is greater than or equal to -1, which if we translate this into words is going to match up with choice A. Question 13, we have the graph of a linear function is shown on the coordinate plane, and we want to know which function best represents the relationship shown in the graph. So for this question here, if we don't want to use the calculator at all, we could use the formula y equals mx plus b. And just know that m represents the slope. But when you have a graph, you could find the slope by just counting the rise over the run. Okay, so we could do rise over run. We could also use that formula from before, the y2 minus y1 over x2 minus x1 formula. But for this question, we have a graph. We'll just count the rise over the run. So I look for a nice point like this at 0, 2. And notice that I'm going here to the point 2, 3. So to get there, I'm going to rise 1 and I'm going to run 1, 2. So I'm going up 1 over 2. So my slope is going to be 1 over 2 or 1/2 because once again, we're going up 1 to the right 2 to get from one point to the next on this line. And now the b value, that's our y-intercept. The line hits the y-axis at y equals 2, so our b value is equal to 2. And now I could just plug into the formula. We're going to have y equals 1/2 x, and then I have plus 2. And this is going to match up with choice D. Now, another thing we could do here is we could go over to stat and then edit. And I could just type in 2 points that are on this line. Notice we have the point 0, 2. So I could put a 0 here, and I'll put a 2 right next to it. So we have the point 0, 2. And then I could find one more point that's on this line. So let's say the point 2, 3. So if I put x equals 2 in column or in L1 here, and then I put the y value, we have y is equal to 3 here. Okay, so I'm just putting 2 points from the line into this table. I have 0, 2, and 2, 3. And now I could do stats, calculate, linear regression. So that's option 4. And I just press enter all the way through. And notice that it gives us the slope is 0.5 and the y-intercept is 2. It will write the equation of the line for us, and that will also bring us to choice D. Question 14, we want to know which statement about f of x is true. And we're talking about the zeros of the function. So what I would want to do here is factor this. So I'm going to take out a greatest common factor of 3. And I'm going to be left with 4x squared. And then I'm going to be left with, for the second term, we'll have minus 12x. And then we'll have plus 9. Okay, so I'm just dividing each of these things by 3 and writing the leftovers on the inside. and I'm going to set this equal to 0. So now from here, I want to use the AC method. And for the AC method here, I identify the A term here is 4, and the C term here is 9. So if I do 4 times 9, I'm going to get 36. And then the B term here is the coefficient of x, and that's going to be negative 12. So now what we want to find here are two numbers that have a sum of negative 12 and a product of 36. And the two numbers are going to be negative 6 and negative 6. So then what I do is I take this expression here on the inside and I break up the middle term, negative 12x, into negative 6x minus 6x. Okay, so we're just factoring by grouping now from this step. So from here, what we're going to take out is another greatest common factor. So I'm going to take out a greatest common factor of 2x, and we'll be left with 2x minus 3 after we divide each of those first two terms by 2x. And now I'll take out a minus 3 because we want to have a matching binomial on the inside. So when I divide by negative 3, I'm going to have 2x. And when I divide 9 by negative 3, I'm going to have minus 3. And I have this all equal to 0 here. So now from here, we have the 3 on the outside, but now we can factor the inside. We have a matching factor of 2x minus 3. And once we take this out, the first term, the leftovers are 2x. And for the second part over here, we have a leftover of minus 3. So now notice what we have here. We have matching factors on the inside. So we could express this now as 3 times 2x minus 3 squared. Okay, anytime we multiply a binomial by itself, we could just say that binomial squared. And now this is equal to 0. So looking at what we have here, we could cross off choices A and B because this is representing kind of like a difference of two squares factoring. So we don't want this. And now all we have to do from this step is identify what the root is. What is the 0? Well, we're not going to set 3 equal to 0, but when we set the inside here, when we set 2x minus 3 equal to 0 and solve, we'll get our 0. So we have 2x minus 3 equals 0. And now if we solve, we're just going to go plus 3 on both sides. And this is going to give us, we're going to have 2x is equal to positive 3. And we'll just make a little bit more space. We'll divide both sides by 2. And this is going to give us x equals 3 over 2. Okay, so this would be the root here. And this is going to give us choice D. Now, one thing I want to point out is we could just type in f of x over here. So I could type in 12x squared minus 36x and then plus 27. And what I could do is I could just type in all of the answer choices. So let's say I type in choices C and D, the f of x in factored form here. If I just type that in, the 3 times, and then we have 2x minus 3 squared. Notice that when we press graph here, so we press graph, that we get the exact same function twice. Okay, so that's how I know these two functions here are equal, that we factored correctly. And then look at where does this curve hit the x-axis. The curve hits the x-axis at 1.5. Okay, so that's why the 0 is at 3 over 2, which is equal to 1.5. 2/3 would be no good because that's over here, and you can see the graph misses the x-axis over here. So choice D is definitely our answer. Question 15, we have a graph of a linear function, and we want to know what are the slope and y-intercept that best represent this linear function. So for this one here, the first thing that jumps out at me is the y-intercept. Our b value is equal to negative 4. And the b value that I'm referring to is coming from the formula y equals mx plus b, the slope-intercept form of a line. M represents the slope, and b is the y-intercept. So the y-intercept here is where the line crosses the y-axis, and that's our b value, which is equal to negative 4. The slope is our rise over run. So all I have to do here is just count the rise over run to get from one point to the next. So let's say I go from this point over here to this point over here. Well, my rise, I'm going to be going up 1, 2, 3, 4. So I'm rising 4, and then I'm going to run 1, 2. So I'm going up 4 over 2, and 4 divided by 2 is equal to 2. And now just be mindful, if I go up 4 over 2 again, notice that it puts me at another point on this line. Okay, so the slope of a line does not change. A line has a constant rate of change. So now I just have to go searching for the answers. So our slope is going first, and our slope is equal to 2. So I'm just going to bubble in choice E. And then the y-intercept is negative 4, and that matches up with choice A. So here is our solution to question 15. Question 16, we want to know which expression is equivalent to this product. Now, first I'll do this by hand. So I'm going to use the distributive property. I'm going to do z times z squared is z to the third. And then we have z times negative 4z is minus 4z squared. And then we have z times 6 is equal to 6 times z, or just 6z. And now next we'll distribute the 5. So I do 5 times z squared is 5z squared, but I prefer to write the 5z squared over here so that we're lining up like terms. And now we have 5 times negative 4z is negative 20z, and then we have 5 times 6 is 30. Okay, so once again, I'm just lining up all of the like terms. So we have just a lone plus 30 over here, so that eliminates these two choices. And then we have 6z minus 20z is minus 14z. So right away, I could see that A is out and choice C is our answer. But let's make sure that the other terms match up. So I have negative 4z squared plus 5z squared. So I just add the coefficients here. And if I do 5 plus negative 4, that's equal to 1. So I get 1z squared. And then I have this lone z to the third term in front. So I'm just going to have z to the third plus. And we could see that this matches up with choice C. But once again, for a question like this, we could just type in the question and our answer choice. So we have z plus 5, but I'll use x. And now I'm going to type in, we have x squared minus 4x, and then we have plus 6. Okay, so the calculator is really like, this really does give you an advantage for a test like this, okay? All you have to do, if you just have the perseverance, is just type in the question and the answer choices, and that'll tell you if the work that you're doing is correct. Now, of course, I would prefer that you learn to do this by hand, because if you're taking an algebra test, like, yeah, you want to learn the algebra, but if your main goal is to pass the test, then just, make sure that you know these calculator techniques. And notice what we have here, the graphs are completely overlapping. If I hit second graph and go to the table, you can see that all of the y values match. For the, like, let's say I have x equals 5, I have matching y values. X equals 8, I have matching y values. So that's how I know that choice C is definitely correct. Question 17, we have the graph of a quadratic function is shown on the grid, and we want to know which statement is best supported by the graph. Well, A is out because it's saying the function has a 0 at x equals 6. But notice that this function hits the x-axis at negative 6 and at 0. So we would have two zeros at negative 6 and 0, not at x equals 6. The minimum value of the function is 9. Well, this one here is not true. This would be true if it said the maximum value. Notice that if we look at the graph of this parabola, that we have a hill over here, okay? So this makes a high point. So this is the highest point on the graph. So this is the maximum y value over here. If we look at this point here at negative 3, 9, this tells us at this vertex, the maximum value of the parabola is 9. If the parabola was opening this way like this, then choice B would be true, okay? Then this would be the minimum value if it was U-shaped, but this is not the case here, so choice B is out. The vertex of the graph is at 9, negative 3. No, it's at negative 3, 9. We write the x first, and then we write the y. So C is out, so just by process of elimination, it has to be choice D. But now let's take a look at this. The equation of the axis of symmetry is x equals negative 3. This is the equation of a vertical line. Okay, anytime you have a equation, or you have an equation in the form x equals k, where this is constant, this is the equation of a vertical line. And this tells you where the line is going to hit the x-axis. So our vertical line is going to hit the x-axis at x equals negative 3. So if I go ahead and draw in this dotted line here like this, down at x equals negative 3, notice that this line is going to act as a line of symmetry for the parabola. It cuts it directly in half this way. So that's how I know choice D is definitely correct. Question 18, we have new houses are built in a neighborhood, and the table shows the exponential change in the number of houses in the neighborhood over the last 6 years. And we want to know which exponential function best models the data. So a question like this, we could just use the calculator. So we're going to press stats, we're going to go to edit, and we're going to fill out this table here. So we're going to type in the x values. We have 1, 2, 3, 4, 5, 6. Okay, so I'm just going to go straight down the line and type in these numbers. And then next we're going to type in the y column. So after the x column is finished, we're going to go up back to L2 here and type in the y values. So we have 27, then we have 35, we have 45, and we have these remaining numbers here. So we have 68, 93, and 124. So now with this, remember the key phrase was that the table shows exponential change. So I'm going to go to stats, calculate exponential regression. I could scroll down to look for it. It's option 0. And now I just press enter a bunch of times here past calculate, and this gives us the values we need. So now let's use this information to write our function for f of x. So we have f of x equals and the equation is in the form of ab to the x power. So we'll write our a value first. We're going to write 18.9, and I'm going to round to the nearest tenth because it looks like for all of these functions here that all of the numbers are rounded to the nearest tenth. And then we're going to have to the nearest tenth, the base of our exponent is 1.4. So I look at the tenths place is a 3, and I'm going to round this up to 1.4. So we have 1.4 now to the x power, and we just scan the answer choices, and this is going to match up with choice C. Question 19, we have to solve this equation and record our answer in the space below. So for this one here, I'm just going to go ahead and use the distributive property. So on the left side, we're going to distribute a negative 3. So we're going to have minus 3m when we do negative 3 times m. And then we have negative 3 times negative 5 is positive 15. And this is equal to, on the right side, we distribute the 2. And we're going to have 10, and then 2 times negative m is minus 2m. So now on the left side, I'll combine like terms. We have 10 plus 15 is 25. So we'll have negative 3m plus 25 equals 10 minus 2m. And now from here, what we could do is we could move the m terms to one side. So maybe what I'll do is I'll just do plus 3m. That way on the right side, we'll have a positive coefficient in front of our m. So now on the left side, this negative 3m plus 3m cancels, and we have 25 equals, and now we have 10 plus m. So now I'll just write this result over here. We have 25 equals 10 plus m, and now to solve for m, we just subtract 10 on both sides. And this is going to give us, we're going to have m is equal to 15. So now I'll just write it out like this. So we have m is equal to 15. But if you have a calculator, you could use this really cool trick. You could press math, press the up arrow, and go to numeric solver here. So I'm going to press this option here. And equation 1, I'm just going to type in the left side of the equation. So I have 10 minus 3, and then parentheses x minus 5. And just know that this trick works for linear equations, okay? For quadratic equations, I would just type this in the y equals, and I would trace the zeros. So for a linear equation, though, you could use the equation solver. And now the right side, we have 2 times 5 minus m, but we're going to use x. And now from here, I just press OK by pressing graph, and then I'm going to press solve. And notice that it gives us our solution of 15. Okay, so for a question like this, we could use a calculator, but you know, if the test is expecting you to show any work for these free response questions, then know how to show the work. But I imagine if you use calculator techniques, like you are going to get some, if not all of the credit, depending on what the rubrics are like for these free response questions. Question 20, which value represents the rate of change of y with respect to x for this function? So this is a linear function, and that means we should get this in the form y equals mx plus b in slope-intercept form because we want to identify the slope of this line. The rate of change of y with respect to x is a fancy way of saying slope, because the slope of a line we could say is y2 minus y1 over x2 minus x1, or we could say the change in y over the change in x. Okay, so that's just another way to interpret slope. So if our goal is to solve this equation for y, the first thing we could do is subtract 2/5 x on both sides. Okay, so we're going to go minus 2/5 x on the left side and minus 2/5 x on the right side. So now we have negative 4 over 7y equals, and on the right side we have negative 2/5 x, and then we have plus 3 over 2. And now once again, the goal is to get y by itself, so we're going to divide both sides by negative 4 over 7. Okay, so that's what we're going to do all across here. And the only thing we really care about here is the coefficient of x. Okay, the slope is the number in front of x. So this equation is now going to say y equals, and on the side here, I'll just go ahead and do the division. We're going to have negative 2/5, and we're dividing by negative 4/7. So when we divide two fractions, we could use keep change flip. So I'm going to change the operation to multiplication, and I'm going to flip the bottom fraction to 7 over negative 4. And now I have a negative times a negative is a positive, and I could just start to simplify this. 2 over 4 reduces to a half, and now I have 7 on top, and on bottom I have 5 times 2 is 10. And remember, a negative times a negative is a positive, so our coefficient of x is going to be 7/10. And now the y-intercept doesn't matter because we only want the slope, which is 7 over 10. But if we wanted to simplify this, we would have 3 over 2 times 7 over negative 4. And for something like this, we have a positive times a negative is negative, and then we have 3 times 7 is 21, 2 times 4 is 8, and we have a positive times a negative is negative. So the y-intercept here would be this. But once again, we only care about the slope, which is the coefficient of x, and that would be 7 over 10. Now, one thing to point out, if we don't want to do this division by hand, we could press alpha y equals enter, and I'm going to do on top negative 2 over 5, and on bottom we had negative 4 over 7. Okay, so we're dividing these two fractions. We press enter, and if I press math enter enter, this turns the decimal into a fraction, 7 over 10. If I divide these two fractions, so I'm going to do alpha y equals enter to pull up a blank fraction, and on top we have 3 over 2, and on bottom we have negative 4 over 7. And we press enter, and then I press math enter enter. Notice that I get negative 21 over 8. Okay, so you can use the calculator to divide your fractions. It's just, a nice way to work through the arithmetic. But once again, we're getting choice D for this question. Question 21, we have a system of linear equations is shown, and we want to know what is the value of x in the solution to this system of equations. So first I'll solve this question algebraically. And if our goal is to find the value of x, I want to eliminate the y variable. So when I want to eliminate a variable, what I'm looking for is creating matching opposites. So I want to transform the y terms here in such a way that I get matching opposites. So the first equation up top, I can multiply by 2. And the second equation on bottom, I can multiply by negative 3. And watch what this accomplishes. We have 2 times x is 2x. We have 2 times negative 3y is negative 6y. And then we have 2 times 7 is 14. And then on bottom, negative 3 times x is negative 3x. And then negative 3 times negative 2y is positive 6y. And then we have negative 3 times 2 is negative 6. And notice here, when I add these equations together, negative 6y plus 6y cancels. And then I have 2x minus 3x is minus 1x. And then on the right side, 14 minus 6 is 8. So then to solve for x, just divide both sides by negative 1, and you're going to get x equals 8 divided by negative 1 is negative 8, and this gives us choice D. But if I want to use the calculator to solve this, I could go to apps and then option 9 down here. I'm going to go to that option, and this is going to help us solve this system. I'm doing the simultaneous equation solver, option 2. And from here, I have 2 equations and 2 unknown variables, and I'm going to press next. So I'm going to press the graph button to go next. And now I just type in the system. I have 1x, and then I have minus, so I'm going to change that plus to a minus by pressing the subtraction. And then we have 3y, and then we have this is equal to 7. So I just press 7, and I press enter. And now the bottom equation, I have 1x, and then I have minus 2y. So I press minus and then 2y, and then this is equal to 2. Okay, so I'm just typing in the original system before we multiply by anything. And now I just press graph, and notice this gives us x equals negative 8, and it also gives us the corresponding y value of negative 5. But the question here only wanted us to find the value of x. So x equals negative 8 is definitely our answer. Question 22, we have a shipping company started with 40 employees, and the number of employees at the shipping company increases at a rate of 7.5% each year. And the question here is, which function can be used to model the number of employees, f of x, at the shipping company after x years? So for this question, it really helps to know this formula. We have a equals p times 1 plus or minus r to the t power. Okay, so for a situation like this, where the number of employees is increasing, we're going to go with 1 plus r. Okay, so I'm just going to modify this formula, and I'm only going with the plus here. So now I just plug in everything. P is the initial value here of 40. So P is equal to 40, and then the rate, r, is the percent. So r equals 7.5%, but I'm going to express this as a decimal. So this means 7.5 divided by 100. And if I turn this into a decimal, this is 0.075. Okay, so now I just plug into the formula, but also instead of using t, I'm going to use x. So I could say f of x is equal to, the initial value is 40, and then we have 1 plus r is 0.075. And this is all being raised to the x power. So now I just simplify this. This is 40 times 1.075 to the x. Okay, so this would be our function f of x. And if we look through the answer choices, this is going to match up with choice B. Question 23, we have the graph of 3x minus y equals 1 shown on the grid, and we want to know which points are in the solution set of 3x minus y is greater than or equal to 1, and we have to shade the 3 correct circles that represent the points. Now for this question, we just have to be very careful. Please don't just shade everything above this line like this. It's very tempting when you see the greater than or equal to just assume you're shading above. But for this, you want to get this inequality in the form of y equals mx plus b. So what we're going to do is we're going to start with this inequality here, and we're going to get the y term by itself. So we could start by doing minus 3x on both sides. And now from here, we have 3x minus 3x canceling, and we have negative y is greater than or equal to negative 3x plus 1. And now to get y by itself, we're going to divide both sides by negative 1. And I'm just going to divide each term on the right by negative 1. But we have to be very careful here. When you divide or multiply a inequality by a negative, the sign of the inequality flips. Okay, so just remember that when you divide an inequality by a negative or you multiply an inequality by a negative, the sign has to flip. And now I just do the division. Negative 3x over negative 1 is positive 3x, and 1 divided by negative 1 is negative 1. So there's the line 3x minus 1, but now I'm shading less than or equal to, so I'm shading under. Now this point would be included in the solution set because it's less than or equal to. So the line is part of the solution set. But now I'm shading everything under, and when I shade everything under, it's going to hit this point, and it's going to hit this point. So these would be the 3 correct circles that represent the points that are solutions to this system. Question 24, we have a sequence can be generated by using the equation shown where a sub 1 equals 5 and n is a whole number greater than 1. So here's the equation that we have here. And one way I like to think of this is that a sub n is the next term. So this is the next term that we're looking for. And a sub n minus 1 is the previous term. Okay, so this is a recursive sequence. In a recursive sequence, the next term is built by the ones before it. So if I start with a sub 1 is equal to 5, then when I want to find a sub 2, for a sub 2, I'm saying n is equal to 2, and I just plug into the formula. This gives us a sub 2 equals, I would have negative 3 plus, and if I do all of the work over here, so I just plug everything in, we're going to have n minus 1, so I'm going to have 2 minus 1 as the subscript. And this would simplify, we would have negative 3 plus a sub 1. So a sub 2, I could say, is negative 3 plus a sub 1 is 5, and negative 3 plus 5 is equal to 2. Okay, so this is going to start out with 5 is the first term. We want to know the first 4 terms in the sequence. We have 5 is first, 2 is second. So right away, this eliminates all the answer choices except B. But I'll go ahead and find the next few terms just so we could see how these types of sequences work. So now for a sub 3, I like to use this interpretation over here. The next term is equal to negative 3 plus the previous term. So the term right before a sub 3 would be a sub 2, which we found to be equal to 2. So now I do negative 3 plus 2 is negative 1, and you could see that negative 1 is the next term. Now if we do this next part correct here, the next term should be negative 4, but now I'm doing a sub 4 is equal to negative 3 plus the previous term. Okay, so the previous term, the one right before a sub 4 was negative 1. So I'm doing negative 3 plus negative 1 is negative 4. And choice B is definitely our answer. Question 25, we have a football player sprinted at a constant rate, and the part of the linear function shown represents the distance the football player sprinted in yards y as a function of the time in seconds x. And we want to know what is the range of the function for this situation. So the range is the set of possible y values. So when I'm looking for the range of a function, I look at the starting point and the ending point. Okay, so we are starting here. So we're going to start here, and we're starting at the point 0, 0. And now we're going to end at this location. Okay, so this is the end, and this is the point 9, 80. And now, once again, the range is the set of the y values. So our y values are going to go from y equals 0 all the way up to y equals 80. Okay, so now I just pay attention to the values on the y-axis, and this line here is taking place between y equals 0 and y equals 80. So now if I want to say between y equals 0 and y equals 80, I could just put y in this compound inequality here and say 0 is less than or equal to y, which is less than or equal to 80, and this will match up with choice C. Now, a very tempting answer choice would be something like choice B, but this would be correct if we were looking for the domain of the function. Okay, for the domain of the function, we're looking for all the set of possible x values. And notice we're starting here when x is equal to 0, and we're stopping here when x is equal to 9. Okay, but the question was asking for the range, so choice C is our answer. Question 26, we want to know which expression is a factor of this quadratic expression here. Now, when I want to factor something like this, I prefer that we have a positive term in front. So the first thing I'll do is take out a -1. So I'm going to take out a minus, and I could write the 1, or I could just leave it out like this. And then I'm going to divide everything here by -1. And that's just going to change the sign of everything. So I'll have positive 6x squared, I'll have positive 19x, and I'll have a minus 20 on the inside. And now what I want to do is I want to use the AC method. So I'm going to identify the A term here is 6, and the C term is -20. So this would be our A term, our C term, and the middle term is our B term. So A times C, if I do 6 times -20, that's going to give us -120. And then our B term is equal to 19. And I'm looking for two numbers that have a product equal to -120 and a sum equal to 19. And if we think about this carefully, the two numbers are going to be 24 and -5. Now, the key to getting these numbers, you can just use a calculator and start listing the factors. Or what I like to do is I do the prime factorization of the number. I take something like 120 and I break this down. So I have 2 times 60, and I could just keep finding factors of 2. I get 2 times 30, 2 times 15, and I could keep going more and more down to 3 and 5. So now, if I look at these factors here, the prime factors, this is going to help me build up to the 2 factors on the inside. Notice here that if I group 2 times 2 times 2 times 3, that gives me 24, and then I have a leftover 5, okay? But we're multiplying to a negative, so one of these is going to have to be positive and one's going to have to be negative. So we're going to have 24 and -5. So now I could split up the middle here. I'm going to have 6x squared, and I'll have plus 24x, and then I'll have minus 5x, and then minus 20. Okay, so I'm just once again using these two numbers to break the middle term into 2 pieces. And now from here, I do factoring by grouping. So I'm going to take the greatest common factor between these two terms, which is 6x, and then we'll be left with an x plus 4. And now the greatest common factor with the next two terms, I'll take out a minus 5 so that we have a leftover factor on the inside of x plus 4. All right, I'm just dividing each term on the inside here by -5. And notice now I have a matching factor on both of these. So now I could do inside these brackets here, I could take x plus 4, and I'm going to have 6x minus 5. Okay, so these are the leftovers here. So I'm looking for which expression is a factor of this. And just scanning through the answer choices here, I could see 6x minus 5 is one of the factors that matches what we have. We don't have a matching factor for x plus 4, so choice B would be our answer. Now, one thing we could do here is we could go to the y equals and we could type in -6x squared, and then we have minus 19x, and we have plus 20. And what we could do is we could look for which of these factors would be a factor of this by finding the corresponding root. So what I mean by that, I'm going to press second window and I'm going to switch the table, the independent from auto to ask. That way I could type in custom values. And I just do this algebra in my head. I pretend that this says 3x minus 5 equals 0. And if I solve for x, I would get 5 over 3. And notice this does not give me a 0 in the original quadratic here, okay? So if one of these is a factor of this quadratic expression, then that means when we set it equal to 0 and solve, that would tell us the root. And if I plug in the x value, I should get a root. I should get a y equals 0. Now, if I set this correct answer equal to 0, I would have 6x minus 5 equals 0 when x equals 5 over 6. If I did plus 5 divided by 6, and watch what happens. If I type in 5 over 6, I get exactly 0 here. And then if I do that for the remaining answer choices, x minus 5 is equal to 0 at x equals 5. Notice I get a non-zero. And then this last answer choice, I would get 5 over 2. And this would give me a non-zero. Okay, so this is way faster than factoring by grouping. But this is an algebra test. And once again, I do want to show how to actually do the algebra. But this is a solid option for a question like this. Question 27, we have the function f of x was transformed to create g of x, which is f of x minus 2, and then plus 5 outside the parentheses. And we have to complete the sentence about this transformation. So we're going to select one correct answer in each box to complete the sentence. We have the graph of f is translated 2 units. Now, if you just have your rules memorized, when you replace an x with an x minus a number, that moves the whole function to the right, whatever that number is. So if I'm replacing x with x minus 2, this sends us 2 units right. Okay, so what's a little bit annoying about this is that if you're just trying to use the rules, so I'm just going to rewrite this here, 2 units right, is that it's opposite when you're going left and right. Like if I have an x minus 2, that's going to send me to the right 2. If I had x plus 2, that would send me 2 units to the left. But once again, we are replacing x with x minus 2, so that's going to send us 2 units to the right. And then next, the plus 5 on the outside is actually going to be going in the same direction. Okay, it's not that opposite idea. We're going to be going up 5 units as well. Okay, so the plus 5 away from the function sends us up 5. So we're going to be going 5 units up. So these would be the 2 correct answers. But once again, if we want to be sure, we could just take the calculator here. We type in the original function x squared. And now we're going to replace x with x minus 2. So I'm going to put x minus 2 in parentheses and square it. And then if I want to add 5 to the whole function, I just tack on plus 5 on the outside. And notice the original function here in blue and the new function in red sends the blue to the right 2 units and up 5 units. Okay, so going to the right 2 units and 5 units up is the correct transformation. For this question, there's 2 properties of exponents we should know. When we have a to the b over a to the c, when we divide exponents that have the same base, we could subtract the powers. And then if I have something like a to the negative b, I could rewrite this as 1 over a to the positive b power. So I'm going to use that idea, and for this, what I'm doing is I'm going to divide the x's first. I'm going to do x to the negative 6 divided by x to the third. Okay, so we're going to divide those first. You could also break this up into 2 separate fractions, like you could say x to the negative 6 divided by x to the third, and then times y to the fourth divided by y to the first. Okay, so this is allowed. You could break a fraction up when all of the terms are attached by multiplication and division. Please don't do this if there's addition, subtraction. Like if you have something like this, please don't try to do something like this, like, oh, this is equal to x over x and then minus like y over y. Okay, this is not correct math. All right, so don't ever do that. But with multiplication and division, you can break a fraction up like this. So now I'm going to use this first rule. I'm going to use it twice. So in the next line here, I'm going to say this is equal to, we have x to the negative 6 minus 3, and then we're going to multiply by y to the power 4 minus 1. So now we simplify this. We have x to the negative 6 minus 3 is negative 9, and then I have y to the 4 minus 1 is y to the third. And now I'm going to use that second property here. If I have something, a number to a negative power, I could write 1 over that number to a positive power. So I could rewrite x to the negative 9 as 1 over x to the positive 9. And now I'm going to multiply this by y to the third. And I could call y to the third over 1. So now 1 times y to the third is y to the third. And on bottom, we have x to the 9 times 1, which is x to the 9th. So it's going to be y to the third over x to the 9. And that's going to match up with choice A. Question 29, we have these 2 tables here, and they have ordered pairs that represent some points on the graphs of 2 lines. And we want to know which system of equations is represented by the 2 lines. Okay, so for this question, you could do things by hand, and you could also use the calculator. So if I want to do things by hand, I want to write the equation of a line. I have to know the slope, and I have to know a point that's on the line. Okay, so this is one formula to know. And then I could also use the formula y minus y1 equals m times x minus x1. Okay, the point slope form equation. You could also use y equals mx plus b, but I prefer to use this one. So here, I'm just going to pick any 2 points, and I'm going to call them x1, y1, and x2, y2. All right, so the first thing I'll do for line 1 is I'm going to find the slope between those 2 points. So I'm going to have negative 2 minus negative 12. And I'm going to divide by 1 minus negative 1. So now from here, we just simplify. We have negative 2 plus 12 is going to make 10, divided by 1 plus 1 is equal to 2. And 10 divided by 2 is equal to 5. So the slope of the first line is 5. Now, you might be thinking, why didn't we find the slope between these 2 points, or the first point and the third point? It wouldn't matter which pair of points you choose. The slope of a line doesn't change. So we're going to get 5 either way. So now what I do is I'm going to plug this slope and let's say the first point into the point slope form equation. So I'm going to have y minus y1 is equal to, so I'm going to use y1 is equal to negative 12. And now this is equal to, the slope is 5 times x minus the x value here is negative 1. And once again, I could use any one of these points to write the equation of the line. I'm going to get the same exact line. So now I have y plus 12 equals 5 times x plus 1. And now I'll use the distributive property, and we'll have 5x plus 5. And now we have y plus 12, so all we have to do now to solve for y is subtract 12 on both sides. And this is going to give us y equals, we'll have 5x minus 7. And I'm looking at the answer choices, and it looks like it's going to eliminate choices C and D, because that first line is 7x minus 9, 7x minus 9. That's not the correct line here. Okay, so now we just have to come up with an equation for the second line. So now we'll go to Stats, Edit, and we will clear out the values from before. I'm just going to press Delete a bunch of times here to clear out these values. And now I could also just start typing here and override what we have. Like if I write -1, enter, it's going to start replacing the values. And then I have 2, and then I have 6. So then next in L2, I'm going to write the corresponding y values, which are 16, 4, and so let's make sure we press enter, and then -12. And now from here, I'm going to press Stats, Calculate, and I want a linear regression equation. So I'm going to go with option 4 here. And I just keep pressing enter, and it gives me all the values that I need. So now line 2, I could just write out by plugging in for a and b. So we're going to have y equals, a is equal to -4, so I have -4x, and my b value is 12, so I have plus 12. And it looks like the last equation in both systems is in standard form, okay? Not in y equals form, the line is in standard form. So I'm just going to add 4x to both sides to get the x and y terms on one side and the constant on the other. And then I look at the resulting equation here after -4x plus 4x cancels, and we're going to have 4x plus y is equal to 12. So that second line, if we scan the answer choices, tells us that choice B is our solution, okay? We have our first equation is here. So the first line should be y equals 5x minus 7, and the second line in our system should be 4x plus y equals 12. Question 30, we want to know what is the range of the function, and notice that we have a quadratic equation that is written in vertex form. So anytime you have an equation like this that's in the form of a times x minus h squared and then plus k, the vertex of your quadratic equation is hk. Okay, so that's how I extract that information from the equation. This tells us that our vertex is going to be at 25, 13. Okay, so that's what's jumping out at me right away. So if I were to produce a sketch of this without a calculator, I'm just going to draw something here, not necessarily drawn to scale, but I'm going out 25 and I'm going up 13. And this parabola, the coefficient a is positive, so this is a smiling parabola that opens upwards. So if I'm looking for the range of the function, this is the set of all possible y values. And I just look for what is the minimum, maximum y value. Well, in this case, we have a positive coefficient in front of our x squared. So we have a U-shaped parabola. So that's going to give us a minimum value. So the minimum value here is at y equals 13. So all of our y values on this graph are going to be greater than or equal to 13. So now I just scan the answer choices and we can see choice D is our answer. All real numbers greater than or equal to 13 is going to be our range. But if that's too stressful to remember, then all you have to do is just go over to the calculator and type in, we're going to have 2/5. I could write alpha y equals enter to pull up a blank fraction. And I have 2/5. I press the right arrow to get out, and then I have x minus 25. And then I'm raising this to the second power. And then I have plus 13 on the outside. Now, if I graph this on a standard window here from -10 to 10 and -10 to 10, notice that we don't see anything. And I'm going to press second window and switch the table back to auto so that we get a bunch of values here. And once again, notice that we're getting these giant numbers here. And we said that the vertex is all the way out at 25, 13. So you would have to go scrolling a little bit to look for when things look kind of normal. And it might jump out here that, oh, my vertex is over here in this neighborhood. So what that would tell me is I would want to go out pretty far past 10. I would want to go to, like, let's say 50. Okay, so if I go in my window out to x equals 50 and I press graph, notice I still can't see anything, and that's because my y-axis is not high enough. So maybe I bump up the y-axis to 100 and then I press graph, And notice now I could see the parabola. So if I want to know what is my minimum y value, because I could see the range is going to be all y values greater than or equal to the lowest point, then I'm going to press second, trace minimum is option 3. And now I go near the turn here. I press enter once before the turn. I go past the turn. I press enter a second time and a third time. And the calculators are not perfect, but this is basically saying x equals 25, y equals 13. So all y values greater than or equal to 13 is our answer. Choice D is definitely correct. Question 31, we want to indicate whether each statement is an example of association, causation, both association and causation, or neither association nor causation. So the first statement we have here is as the outside temperature in degrees Celsius increases. Okay, so as temperature increases, the number of minutes it takes for a bowl of ice cream to melt decreases. Okay, so the number of minutes for ice cream to melt decreases. Now, this is going to happen no matter what. Okay, like this is something that is going to be definitely causation. Now we just have to think about whether there's association involved. But yes, increasing heat causes ice cream to melt faster. Okay, that's just science. All right, there's no like maybe here. This is definitely causation involved. Now, association, I also like to think of as correlation. And if we were to record data looking at the relationship between temperature in degrees Celsius and the amount of time it takes for a bowl of ice cream to melt, there would definitely be an inverse relationship that as the temperature goes up, the amount of time it takes for the ice cream to melt would go down. So here we would say both association and causation. Now for the second part here, we have as the sales of winter coats increase, the outside temperature decreases. This one here is a maybe situation. Like, yes, there is going to be a drive in sales of winter coats around winter time as the outside temperature decreases. Okay, these two are definitely linked together, but this is not causation. Okay, someone could be really, really stubborn and be like, well, you know what? I'm just not buying a coat because you made this observation, and now just out of spite, I'm not buying a winter coat, and I'll just tough it out all winter just wearing a hoodie. Okay, so this one, there is no science behind this. Like, this is not guaranteed to happen. This one here is definitely like a maybe of some sort. Okay, so yeah, maybe I'll buy a winter coat as the temperature decreases, but maybe I'll just keep my same winter coat from 10 years ago and just save money. So yes, sales will go up, and there's definitely an association between the two, but this one's going to be association only, okay? Because people could just, once again, hold out and not buy a winter coat this upcoming winter season. Now, the ice cream can't hold out. The ice cream can't be like, hey, I'm just not going to melt as you up the temperature. Like, no, there's no control over whether the ice cream melts or not, all right? That is, once again, the heat is just going to do that to the ice cream. So this second statement here is association only. Question 32, we have dance lessons are offered at 2 studios, and the cost of dance lessons at each studio is shown. So we have Studio Q charges a $30 registration fee plus $80 per month. Now this part here represents the rate, and this is the fixed amount. So for questions like this, what I'm thinking of is I'm thinking of y equals mx plus b. So y equals mx plus b, but in the context of word problems like this, m we just treat as the rate of change. So this is the rate, and b is the fixed amount. Okay, if I were graphing the equation of a line, m I would treat as the slope, the rise over the run, and b would be the y-intercept. But in these word problems, m is the rate and b is the fixed amount. So if I had to write the equation of not the equation of a line, if I just had to write an equation for Studio Q, I would say the equation for Studio Q would be 80x and then plus 30, okay? Because, once again, the registration fee is the fixed amount, and the rate here is going to be $80, all right? The giveaway phrase for the rate is the word per, $80 per month. So that's telling us the rate of change with respect to time as time goes on. So now I'm going to say this is equal to the equation, or I'm sorry, the expression for R. We have the rate here is $65 per month. So we would say 65x and then plus 105. So now from this step, we'll just solve this equation for x. So I'm going to do minus 65x on both sides to get all the x's on one side. Okay, so we could do this first. And now 80 minus 65 is 15. So I have 15x plus 30 is equal to 105. And now from here, I'll just subtract 30 on both sides to get the x term completely alone here. And now we have 15x is our only x term left, is equal to 105 minus 30 is 75. And now from here, all we have to do is just divide both sides by 15. And if we do the division here, 75 divided by 15 is 5. So our solution here, how many months will the total cost of the dance lessons be equal, is going to be 5 months. Question 33, we have the graph of a linear function shown here, and we want to know which statement is best supported by the graph of the function. So let's just go through the answer choices. We have the slope of the graph is 1/2. That is definitely not true, because if the slope of our line is positive, that means the line is going up, not down. All right. Also, if I just count the slope here, counting the rise over the run, the slope of this line is going to be -1/2, because to get from one point to the next, I'm going down 1 and then to the right 2. So I'm rising -1 and I'm running 2. So the slope would be -1/2, not +1/2. The x-intercept of the graph is 6. Well, the x-intercept is where the graph crosses the x-axis. And notice that's happening at x equals 6. So choice B is definitely correct. Now, the 0 of the function is 1/2. 0 and x-intercept, these mean the same thing, okay? These are the same thing. The 0 is where the graph crosses the x-axis. And we already said that the graph is crossing the x-axis at 6, not at 1/2. Okay, so this is also not true. And now the y-intercept of the graph is 6 is a false statement. The y-intercept here would be equal to 3 because this line hits the y-axis at y equals 3. So choice D is also not correct. Choice B is definitely our answer. Question 34, we should know the difference of two squares formula. Anytime we have something in the form of a squared minus b squared, we could factor this nicely to a plus b times a minus b. So for something like this, what I'm doing is I'm taking the square root of each term, and I'm just going to use that when we're factoring. So I have the square root of 16m squared. I'm going to do the square root of 16 is equal to 4. And for the interest of this question, we're going to say the square root of m squared is equal to m. Now, the reason I bring that up is this is a very technical detail that pops up later in math, but something like the square root of x squared, I don't say is equal to x. I say it's equal to absolute value x. Or in some cases, I could write this as plus or minus x. But in this case here, it looks like every answer choice is just going with the plus. So that's what I'm going to include over here. And then the square root of 81 is equal to 9. So now what that helps me find here is how to factor this. So I'm going to write the square root of the first term first in both parentheses. So the square root of 16m squared is 4m. And I'm going to write that twice. And then I have plus or minus the square root of the b squared term is 9. So I have plus 9 and minus 9. And now if I scan through the answer choices, we could see here, this is going to match up with choice D. Question 35, we have the equation of line K is given here. And then we have line N is parallel to line K and passes through this point. And we need to determine an equation that represents the relationship between x and y for line N. Now, one thing we have to know here is that parallel lines have the same slope. Okay, this is a very important detail. So if I look at the original line here, line K, I just look and say, all right, the slope of this line is equal to -1. I'm just making use of that y equals mx plus b formula. And the coefficient of x, when our equation is in the form of y equals, tells us the slope. Okay, so whatever the slope of line K is, that's going to be equal to the slope of line N. Okay, so I could say the slope of line N. So for line N, let's write that over here. For line N, the slope is equal to, we're going to have -1. And it's going to pass through the point -5, 7. So for this, I'm going to call this point here x1, y1. And I'm going to use the formula y minus y1 equals m times x minus x1. Okay, the point slope form equation. And now I just plug in. I have y minus y1 is 7 equals the slope is -1. And then I have x minus -5. I could write minus 5, or I could just write plus 5 here. And now I could distribute the negative, and we're going to get -1 times x is -x, -1 times 5 is -5, and we have y minus 7 equals. So now I'll just do plus 7 on both sides, and this is going to give us our final answer. I'll write it over here. We're going to have y equals -x, and then we do -5 plus 7 is +2, and here is the equation of the line. Question 36, we have a bicycle rental company that charges a fixed rental fee for the first 30 minutes and a cost per minute for each additional minute. And then we have the table shows the linear relationship between the total cost in dollars to rent a bicycle and the number of additional minutes a bicycle is rented. And we want to know what is the rate of change of the total cost in dollars with respect to the number of additional minutes. So if we're looking for the rate of change, we're looking for the slope. And for this one here, we can use the slope formula and just find the slope between any 2 points. So let's say I call this first point here x1, y1, and I call the second point here x2, y2. I could just find the slope between these two pairs of points here. So we have m equals, and now y2 minus y1, I'm going to do 3.40, and I'm subtracting 3.05. And then I'm going to divide by, we have 20 minus 15. And the units here, remember, is going to be the total cost in dollars with respect to the number of additional minutes. So that's where the dollars per minute is coming from at the end here. So dollars per minute is going to be our unit. So dollars per minute. And now if I do the subtraction, this is going to give us 3.40 minus 3.05 is 0.35. And if I do 20 minus 15, I get 5. And once again, it's dollars per minute. So we have this many dollars per minute. And if I just do the division here, this is going to work out to, we're going to have 0.07. So this many dollars per 1 minute. Okay, so I'm just dividing these numbers here, and this is going to match up with choice C. Now, one thing we could do is we could go over to stats, edit, and we could enter in some values here. I could type in 15, I could type in 20, and I only need 2 points to determine a line, so I don't have to type in all of the points. I could just type in a few, and it's going to give me the same answer. I have 3.05 for the first y value, and then I have 3.40 for the second y value, and then 4.45. And I could go over to stats, calculate, and I'm doing a linear regression, but I'm looking for the a value here. I'm looking for the slope. And if we calculate this, notice our a value is 0.07, which does match choice C. So that's definitely our answer. Question 37, we have a student borrowed $480 from a friend, and he agreed to make monthly payments of $96 with no interest until the loan balance was paid off. And then we have the function here, f of x models the situation where f of x represents the remaining loan balance in dollars after the student has made x monthly payments. And here's our function. We want to know which statements are true about the domain and range of the function for this situation. So here I would really pay attention to what each of these numbers mean. $480 represents the initial amount of money that the friend borrows, and they're paying the friend back, and they're making payments of $96, and X represents the number of monthly payments. Okay, so that, if I'm just looking at this here, I see that we're doing 480 minus 96 times X, because as they pay the money back, the amount of money that they owe starts to shrink. But what we could do here is we could go over to the y equals, and we'll type in 480 minus 96x. Now, if we go to graph this in standard mode here, in the -10 to 10 window in the X and Y, notice that we don't get the best picture of what's happening. And that's because the student borrowed $480. So we would have to bump the y-axis up to, I'll bump it up to 500. Okay, I'll put our y maximum here. And if we look, we're not going to be going back in time. So I'll put x minimum of 0. And then I look here and notice that the line hits the x-axis at x equals 5. So that's going to be a significant value here. If I go to the table and press second graph, notice at 5, the y value is equal to 0. So that's going to be important when we're choosing our correct answer. So now to finish off this question, the domain is the set of all possible x values, and the range is the set of all possible y values. So now let's think about this in the context of the question. Once again, f of x represents how much money the student still owes. In the beginning, they owe $480, and they keep making payments of $96 each month. So if we look here, the domain would be going from 0 to 5. Okay, 0 to 5 makes the most sense. So the domain of the function is going to go from 0 to 5. That is the set of possible x values here, where this line is happening. Okay, from the beginning when they first borrow the money up until 5 months later until they pay all the money back. So the domain of the function is going to match up with this answer choice here. And now for the range, notice that it's going from 480 down to 0, but it's going down by 96 each time. So these are the y values that we have to look for. And if we scan the answer choices, we could see that all of the y values show up in the last answer choice here. We have 0, 96, 192, 288, 384, and 480 is the set of all the y values in the range. So these are the two correct answers. Question 38, we want to know what are the solutions to the equation that we have here. And this is a quadratic equation, but it's in factored form. So once you have your quadratic equation factored, what you could do is you could set each factor equal to 0. So we could set x plus 13 equal to 0, and we could set x minus 6 equal to 0. Because the idea is anytime you have a product of two numbers, the only way a product of two numbers, like let's say a and b, would equal 0 is that either a is equal to 0, or we could have b is equal to 0, or we could have a situation where a and b is equal to 0. Okay, but basically anytime we have a product, one of these factors has to be 0. So here we're going to find the two possibilities. Either the first factor is equal to 0 or the second factor is equal to 0. So in this situation here, we just solve by doing minus 13 on both sides. And that's going to tell us x equals negative 13. And notice that that wipes out two answer choices. And now from here, I'll do plus 6 on both sides. And that's going to give us our second solution of x equals positive 6. And that's going to match up with choice B. Question 39, we have a sample of a substance with an initial mass of 963 grams that's decaying at a rate of 27% per hour. So we just have to make note here that the substance is decaying. And what we have to do is create a function that can be used to find y, the mass of the substance in grams, remaining after x hours. So for this question, I'm thinking of this formula here. We have a equals p times 1 plus or minus r to the t power. Okay, so this is used in situations where we have compound interest, but anytime we have exponential growth or exponential decay, this is the formula that we want to use. But since the mass or the substance is decaying, we're going to go with the minus here. Okay, so we're going to subtract in this case, because once again, this is the $1 million phrase right here, decaying. So we're going to make the function also in terms of y and x. So this is what's inspiring the function that we're going to create, but instead of using a and t, we're going to use y and x. So what we're going to have here, I'm just going to define the pieces. P is the initial amount. So I could say y equals, once again, instead of a equals, p is 963. And then I have 1 minus r is the rate. Okay, so the rate here in the context of this question is 27%. Okay, so I'll just make that a little bit neater. So we have 27% is our rate, but I'll just clean that up here. So the rate is the r value here. So we have r equals 27%, and this is equal to 0.27. Okay, so I'm going to do 1 minus 0.27, and now my power, instead of t, I'm going to use x, because once again, they want us to create a function that could be used to find y, the mass of the substance in grams remaining after x hours. So now we'll just simplify here. We're going to have 963 times, and then when we do the subtraction here, this is going to be 0.73 after we do 1 minus 0.27, and this is being raised to the x power, so here is our equation. Question 40, we want to know which graph best represents the solution set of this inequality here. Now, one thing that jumps out at me right away is that this is a strictly less than inequality, which means that our line is going to be a dotted line. So looking at the answer choices, right away we could eliminate choices B and D. Now, one thing we have to be very careful of here, it's very tempting once we see the less than to just assume that we're shading under. But the only way we could start determining whether we're shading over or under is when our linear inequality is in the form of y equals mx plus b. Okay, now technically it would be in the form of y less than or greater than mx plus b, but we still want to solve this for y. So one thing we could do first here is we could subtract 6 on both sides. And now on the right side, 6 minus 6 cancels, and we're going to have 3x minus 6 is less than 2y. And now from here, I divide everything by 2. And this is going to give us, we're going to have 3 halves x minus 6 divided by 2 is 3 is less than y. But now we have to be able to say an inequality multiple ways. I could say 3 halves x minus 3 is less than y, or I could say that y is greater than 3 halves x minus 3. This has the same truth value as what I have here. So now this is a strictly greater than situation. So we're going to be shading above. Okay, so this tells us to shade above the line. Okay, and the line is going to be, once again, a dotted line. So we're shading above. So the correct answer here is actually choice C, because once again, we have to get this in the form of y equals mx plus b, but in this case, y greater than mx plus b. So choice C here is our answer. Question 41, we want to know what is the slope of the line that passes through the points 10, 18, and -5, -12. So for this question here, we could just use the slope formula. We can use the calculator for this question, but we'll just go ahead and use the slope formula. So remember, m equals y2 minus y1 over x2 minus x1. So for this question here, I'm just going to plug in, and we have m equals y2 is -12, and we're subtracting y1 is 18, over x2 is -5, and we're subtracting x1 is 10. So now we just do the subtraction here. We're going to have -12 minus 18 is -30. And now we're dividing by -5 minus 10 is -15. And now a negative divided by a negative is positive, and 30 divided by 15 is 2. So this is going to match up with choice B. Question 42, we want to know what are the solutions to the equation that we have here, and this is a quadratic equation. So just know anytime you have a quadratic equation in the form of ax squared plus bx plus c is equal to 0, the solutions here we could find by using the quadratic formula. We have x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So for this question here, the first thing I would do is add 3x to both sides, because we want all of the terms on one side and we want 0 on the other side. So this would give us, after these terms cancel, we would have x squared plus 3x minus 2 is equal to 0. And now I could just use the quadratic formula. My a value is equal to 1, because if I don't have a number in front of x squared, the invisible number is 1. I have b equals 3, and I have c equals -2. So now I just plug into the quadratic formula. I have -b, so I'm going to have -3 plus or minus the square root of 3 squared, and I have -4 times a times c, and we're dividing all of this by 2 times a. So now I just have to simplify here. This is going to give us -3 plus or minus square root of, and we're going to have inside the square root here, we're going to have 9, and then -4 times -2 is +8. So we're going to have 9 plus 8 on the inside, which is going to simplify to 17. And this is all divided by 2 times 1 is 2. So we're looking for -3 plus or minus square root of 17 over 2, and this matches up with choice C. Now, one thing we could do for this question is we could type the answers on the main screen. So I could do alpha y equals enter. And if I just go through all of the answer choices, let's say by the time I get to choice C, I type in -3, and let's say I do plus square root of 17. So I'm pressing second x squared, and we're dividing all of this by 2. And I press enter. A nice little feature I could go with here is I could store this as the letter A. So alpha math pulls up the letter A. And now every time I write alpha math, or I write the letter A, I get this really long decimal. So now if I plug back into the original equation here, I have x squared, so I'm going to do a squared, and then -2. And let's see what happens when I type in -3 times x, or -3 times the solution a. Notice that I get matching decimals. Now, if I also want to check the other root, remember it was -3 plus or minus square root of 17. I could also repeat this process by doing -3 minus square root of 17, and I'll store this as the letter b. So I'll press alpha apps to pull up the letter b, and now if I plug this into the original equation, if I do alpha b, square it, -2, that's the left side of the equal sign. And if I do -3 times b, notice that I get the exact same decimal here. Okay, so these solutions, -3 plus or minus square root of 17 over 2, are definitely good. Question 43, we have in the expression shown, x is a value where the expression is defined. And we want to know what is the simplest form of the expression. We want to write our answer in the form of ax to the b power. So for a question like this, we have to know the following exponent properties. If we have a to the b times a to the c, this is a to the b plus c. If I have something like a to the b to the c power, this I could express as a to the b times c. All right, and there's some other rules too, where if we have something like ab to the c, this could be simplified by doing a to the c, b to the c. And then, of course, I'm running out of space here, but if I have a negative exponent, let's say I have a to the negative b, this I could write as 1 over a, let me just make that neater, as 1 over a to the positive b. Okay, so these are all the things we want to keep in mind as we're doing these questions. So I'm just going to rewrite the actual question itself. And the first thing I would handle is this parenthesis term on the right. So this I could say now is equal to 2x to the 8. And then I'm going to do 3 to the second power. And then I'm going to have x to the negative 1 to the second power. So here I'm just raising each of these terms to the power 2. So I'm using this property over here. And now if we simplify things a bit, this is equal to, we're going to have 2x to the 8th. And then 3 to the second is 9. And then x to the negative first to the second, I multiply negative 1 by 2. And I'm going to have x to the negative 2. Okay, so this makes things a little bit simpler. And now from here, I could just multiply the numbers together. Now, if you want to just put things in parentheses like this is optional. You could write 3 squared in parentheses like this, but it doesn't matter. I could just, once again, write things in parentheses like this, but at the end, the parentheses are just going to disappear anyway. So now I'm going to choose to multiply the numbers together. I'm going to do 2 times 9 is equal to 18. And now we have x to the 8 times x to the negative 2. So I'm using this property of exponents. That's going to simplify to 8 plus negative 2. So you see here, we could multiply x to the 8 by x to the negative 2 and get the result by adding their exponents. So now I just simplify, and this is 18 times x to the 6th power. And this is our final answer because we have to be in the form of a number times x to a number. So here's our solution. Question 44, we have a table of values, and this represents points on the graph of a linear function. So once again, we have to write the equation of a line. So for this one, we could just press stats, edit, and we could clear out the table from before. And remember, it only takes 2 points to determine a line. So I could type in any pair of points here into this table. I'm going to put negative 1 and let's say 3. And then I'll write in the corresponding y values. For negative 1, the corresponding y value is 27 over 7. And then for the next part here, for x equals 3, we have y equals 11 over 7. Okay, so now I could just press stats, calculate, linear regression is number 4, and we just keep pressing enter. And here are the values that we're going to need. So for this question here, just looking at the a value, the coefficient of x should be negative. So that eliminates these 2 answer choices here where the coefficient of x is positive. And now I'm looking at the constant term at the end, the b value. And here I'm just thinking 23 divided by 7, I know is going to be equal to, or I'll just say roughly equal to, and I'm going to say 3 point something, something, something. Okay, because I know my 7 times tables, we have 7, 14, 21, and then we have 28. All right, I'll just make that one a little bit neater. That 4 wasn't my best 4. And from here, I could see that 23 is between 21 and 28. So I know that 23 divided by 7 is going to be 3 point something something, which this is 3 point something something right here. If I did 31 divided by 7, 31 divided by 7, 31 is between 28 and 25. So this would be roughly equal to 4 point something something. Okay, so I could just check to see if 23 divided by 3 is this, but it will match this. Okay, so this, once again, I know is 4 point something, which is not equal to this b value here. So A is definitely our answer. Now, for a question like this, if you want to do it by hand, you would have to find the slope by hand. So we could start by finding the difference of any pair of y values and then dividing by the difference of their corresponding x values. So here, let's say I do 11 over 7 minus 27 over 7, and then I divide by 3 minus negative 1. Okay, so I'm basically just using the x1, y1, x2, y2 formula, and I'm doing y2 minus y1 and dividing by x2 minus x1. So this slope, if I simplify, 11 minus 27 is going to give us negative 16 over 7, and we're dividing by 4. 3 minus negative 1 is 4, and I'll call this 4 over 1, so that now I could simplify this, and I just do keep, change, flip, and 16 over 4 simplifies to 4. This whole division problem here simplifies to negative 4 over 7. So right away, I could see the slope of negative 4 over 7 is showing up. But now, if I want to write the equation of a line, what I could do is I could use the point slope form equation. So I'm going to use y minus y1 equals m times x minus x1. So from here, what I could do is I'll just use this point x1, y1 to plug in. So I have y minus 27 over 7 equals m is negative 4/7. And then we have x minus x1 is negative 1. So I'm doing x minus negative 1, which I could just change that all at once to x plus 1, just so we don't have to rewrite a whole new line. Okay, and then from here, what we're going to do is use the distributive property. So we're going to have y minus 27 over 7 equals negative 4 sevenths times x. And then negative 4 sevenths times 1 is minus 4 over 7. And now just add 27 over 7 to both sides to solve for y. And from here, after these terms cancel, we have y equals negative 4 sevenths x. And then if I do 27 over 7 minus 4 over 7, that's going to give us 23 over 7. And that matches exactly what we need at the end here. So A is definitely our answer. Question 45, we have the quadratic function f has vertex 4, 15 and passes through the point 1, 20. And we want to know which equation represents f. So for this question here, we can make use of the vertex form of a quadratic equation. So we have y equals a times x minus h squared and then plus k. And just know that hk is the vertex. So I could plug into this formula and now we could say y equals, and we have a times x minus 4 squared and then plus k, and k is equal to 15. And now the next thing that we know is that the point 120 is on this parabola or on this quadratic equation, the graph of it. So we could plug in x equals 1 and y equals 20, and that's going to tell us what a is. So we plug in and we have 20 equals a times, and then we have 1 minus 4 squared plus 15. And now we just have to do the algebra here. We have 20 equals, and 1 minus 4 is going to give us negative 3. So we're going to have negative 3 squared times a, and then plus 15. And now negative 3 squared is 9, so this turns into 20 equals 9a plus 15. And now we just solve for a. We're going to subtract 15 on both sides. And we're going to have 5 is equal to 9a. And now just divide both sides by 9. And we have a is equal to 5 over 9. So now the full equation, now that we have a, we could say now is equal to, so here's our final answer, y equals 5 over 9. And then we're multiplying by x minus 4 squared plus 15. Okay, so once again, we're just plugging in the a value here. That was the only term that's missing so that we could find our answer. And now we just scan the answer choices, and this is going to match up with choice B. Question 46, we have a line is graphed on a coordinate grid, and we want to know which statement best describes the line. So anytime you have a vertical line, it's in the form of x equals a constant. So here, just looking at this line, I see that it hits the x-axis at 6. So the equation of the line would be x equals 6. All right, that's the equation of this line. If you want to know, like, why does that equation turn out like this? Well, if we just pick out a bunch of points on this line, like let's say I pick out these 3 points here. This is the point 6, 7. This is the point 6, 4. And then down here is the point 6, negative 4. Okay, so I'm just make that a little bit neater. So we have 6 and then negative 4, and I'll put that in parentheses. So now think about, what do all of these points have in common? The x value is equal to 6. So that's why the equation is x equals 6. So now just noting that is going to eliminate choices B and C. We're not going to go with y equals 6. Y equals 6 would actually be the horizontal line like this. So I'll just make that a little bit neater. Y equals 6 would be a horizontal line going through the y-axis at 6. So that's why we could eliminate these two. And now for this part, I'm going to introduce you to slope guy. All right, if you've never seen slope guy before, here's slope guy. And slope guy is really helpful for remembering the slopes of lines. So I'll just make that a little bit neater. So here is slope guy. And the way slope guy works, the way I break this down is, if you have a positive slope, your line goes up. If you have a negative slope, your line goes down. If you have a vertical line, your slope is undefined. Okay, so this U under his nose, or on his nose here, just means undefined. Okay, so that's how we interpret this. And then if you have a horizontal line, the slope is 0. So that just tells me we have x equals 6 is a vertical line. The slope is undefined. So choice D is our answer. Question 47, we have the graph shows two lines representing the equations y equals 2x plus 5 and x plus y equals 1. So from here, we want to know which ordered pair is in the solution set for the system of inequalities where we have y is greater than or equal to 2x plus 5 and x plus y is less than or equal to 1. So if I just look at that first equation, y equals 2x plus 5, that would point to this line over here, because the y-intercept, this is in slope-intercept form, that the y-intercept here, our b value, is equal to 5. So when I'm looking at y is greater than or equal to this line, I would just shade everything above this line like this. Okay, so that's how I would start this one off. But now for the second inequality, we have to be careful. If we have x plus y is less than or equal to 1, we have to solve this for y before we start shading anything. Okay, so we're going to have y is less than or equal to negative x plus 1. And now here we have that second line. This is the graph of y equals negative x plus 1, but now we're going y less than or equal to, so we're shading under. Okay, so we're going to shade under that second line, and that tells us our solution set is going to be in this space over here. Okay, so here is our solution set. So when we go through the answer choices, let's see, negative 5, 0 is right in that solution set. So right away, I can see that this is the answer. 0, 7, the problem is with 0, 7 is that it's only a solution to one of the inequalities, not both. So this answer choice is out. 5, 0 is not a solution to either inequality. So this one is like really the wrong answer. And then 0, negative 7 is only a solution to y less than or equal to this, y less than or equal to negative x plus 1. So that's why this one is out. Now, one thing we could do here to be extra safe is plug in the point negative 5, 0 into both inequalities to make sure that they both check out. Okay, so x is going to be negative 5 and the y value here is 0. So we plug that in and we're going to have 0 is greater than or equal to 2 times x, and we're plugging in negative 5 for x and then plus 5. And now if we simplify the right side, we have 0 is greater than or equal to negative 10 plus 5 is negative 5. And this is a true statement. So this point definitely satisfies that first inequality. And now if we plug it into the second inequality, we'd have x is negative 5 plus y is equal to 0 is less than or equal to 1. And negative 5 is definitely less than or equal to 1. So plugging in negative 5, 0 to both inequalities gives us two true statements. So A is definitely correct. Question 48, we have a linear function f, and we have f of negative 3 equals 0 and f of 5 equals negative 4. And we have to complete function f in slope-intercept form. So what we have here is we have f of x equals some number times x plus some number. So they're writing f of x in mx plus b form. So we need to come up with the equation y equals mx plus b for this question here. Now, one thing to point out is that when we have these function values here, we could write them in the form of a point. So f of negative 3 equals 0 has the same meaning as the point negative 3, 0. Okay, this means when you have notation like y equals f of x, the x value goes inside the function, and whatever it's equal to is the y value. So I could just write f of negative 3 equals 0 as the point negative 3, 0. And then the same idea behind this point here, I could say that this is the point 5, negative 4. Okay, so these are the 2 points I'm going to throw in the calculator. So we'll go to stats, edit, and we'll just replace the 2 points that we had earlier with these 2 points. So we have negative 3 is our first x, and then we have 5 is our second x. And then we go to the y values here. When x is negative 3, the corresponding y value is 0. And when x is 5, the corresponding y value is negative 4. And now from here, we just press enter, and I'm going to go over to stats, calculate. Linear regression is option 4. We press enter a bunch of times here, and this gives us the values we need. So now we could just use this information to answer the question. Our slope is the coefficient of x, that's the a value, and the a value is negative 0.5, and that matches up with choice D. And that's once again going in front of the x, so we're going to bubble in choice D here. And then next we have our b value, our y-intercept, is negative 1.5, and that's over here at choice C, but that's the constant after the x term. So we have plus our constant is choice C, negative 1.5. So these are the 2 correct answers to this question. Question 49, we want to know which statement about the graph of f of x equals 35 times 1.4 to the x is true. And for this one, I'll do it by hand, and then we'll use the calculator to check our answer. So choice A, we have the y-intercept of the function is 0, 35. So for this, we could just plug in x equals 0 to the function and see what happens. So we have 35 times 1.4 to the 0, and 1.4 to the 0 power is equal to 1. So we would have 35 times 1, and 35 times 1 is equal to 35. So this tells us that the point 0, 35 is our y-intercept. So right away, we could see that A is true. This is going to be our correct answer. But of course, we should check why the other answers are not true. Well, for this one, it says the x-intercept of the function is 1.4, 0. But the problem is, the reason why choice B is no good is if we plug in 1.4 to the function, this is going to give us 35 times 1.4 to the 1.4 power. And this, I think we could see here, is clearly not equal to 0. Okay, this value here, let's just make that a little bit neater, but this value here is clearly not equal to 0 because 1.4 to the 1.4 is not 0, and when we multiply a non-zero by 35, we're not getting 0. So that's why choice B is out. And then choice C, the reason why this is no good, it says the graph of the function is decreasing for all values of x. But this is an exponential function where the base 1.4 is greater than 1. So anytime you have a base greater than 1 and you raise it to the x, you're dealing with exponential growth. So f of x is going to be in the shape of something like this. Okay, it's going to be looking something like this. So it would be increasing for all values of x, not decreasing. So C is out. And then we have the asymptote of the function is y equals 0.4. But here the asymptote of the function is going to be y equals 0. Okay, in a moment I'm going to use the calculator to check it, but that's going to be where the exponential function is approaching but never going to touch. Okay, so it would be approaching the x-axis, which is really the equation y equals 0. So that's why choice D is out. So now let's use the calculator to check our answer. So we're going to type in y equals, and we have 35 times, in parentheses, we have 1.4, and we close the parentheses and raise this to the x power. And now if I go to graph this in standard form here, I'm not going to be able to see what's going on. But if I go to the table second graph, I could see some of the values that we're looking at. So maybe I'll bump this up to like 400. Okay, I'm going to up the window here. The y maximum I put up to 400. And now I press graph and I could see our exponential function here. So now if we go through everything, you could see when x is equal to 0, y is equal to 35. So choice A is definitely correct. Between 1 and 2 is where 1.4 would be. And you could see that in that neighborhood here, at around 1.4, we're not hitting the x-axis. So that's why B is no good. The graph of this function is clearly increasing all the time, not decreasing. And the asymptote of the function is not y equals 0.4. I said before that it's happening at the x-axis, y equals 0. And if I write in y equals 0, you could see that this graph is approaching that red line, but it's never going to touch here. So choice A is definitely our answer. And now finally, question 50, our last question. We want to know which expression is equivalent to k squared minus 5k minus 6. This is a quadratic expression. There's a leading term of k squared with a coefficient of 1. So that means we could use the following factoring technique. We could look for two numbers that have a sum of -5, and the two numbers would also have to have a product of -6. So if we think about the two numbers that work are -6 and +1. Okay, so I'll say -6 and +1. And the check here is -6 plus 1 is -5. -6 times 1 is -6. So now I just factor this to k minus 6 times k plus 1. And this is going to match up with choice C. If we want to check our answer with the calculator, we could just type in the original question. So we could type in x squared minus 5x minus 6. And then we just type in all of the answer choices. But I'm saying here choice C is correct. So let's just say we want to check our answer. We're going to do x minus 6 in parentheses, and then we open another set of parentheses and type in x plus 1. And now if I press zoom 6 to put the graph back to normal, notice that these graphs completely overlap. So choice C is definitely our answer.